North Korea claims it's created a thermonuclear bomb. So how is that any worse than just a regular old nuclear bomb? Blessings of the glorious leader be upon you. I'm Julian here for D News. North Korea is a country that ranks in my top 2 Koreas and recently announced it has successfully detonated a hydrogen bomb. The country has detonated atomic weapons in the past, but an H-bomb could be a game changer. First, a quick primer on atomic weapons. The original A-bombs, like the ones the US dropped on Hiroshima and Nagasaki, worked by splitting the nuclei of heavy elements into smaller ones in a process called fission. They used either uranium-235 or plutonium, which, when split, release neutrons that split more atoms in a chain reaction. The resulting elements have a smaller total mass than the original. So, where did all that missing mass go? Well, if you remember Einstein's equation E equals mc squared, you know that energy is equal to mass times the speed of light squared. This means that a tiny amount of mass is equivalent to huge amounts of energy. If you're making a weapon, this principle means the amount of uranium-235 you can fit in a coffee mug packs the same punch as 20,000 tons of TNT. But A-bombs leave a lot of atomic fuel unsplit, which is where hydrogen bombs come in. An H-bomb detonation starts the same way an A-bomb does. Uranium-235 or plutonium is split, releasing tons of energy. However, right next to the A-bomb primary is, you guessed it, hydrogen. More specifically, deuterium and tritium. Deuterium is a stable hydrogen isotope with 1 proton and 1 neutron, and tritium is also an isotope with 1 proton and 2 neutrons. The 2 isotopes can be smashed together to form helium in a process called fusion, like what happens in the core of our sun. But that only starts to happen at 50 million degrees Celsius, hence why these devices are called thermonuclear bombs. The X-rays from the exploding atomic bomb have enough energy to implode the hydrogen, and they travel at the speed of light, so they get to the hydrogen before the shock wave blows the bomb apart into less deadly chunks. Of course, the fusion fuel produces plenty of energy itself, but it also produces more free neutrons, which can be used to make the fission more efficient. For this reason, the H-bomb is often wrapped in a tamper of more uranium-235, meaning it explodes in stages of fission to fission again, like a turducken of Armageddon. Theoretically, it could have several stages, and designs with up to 7 layers have been drawn up, but eventually, what's the point? I mean, just how dead do you need to make something? The largest man-made explosion ever was a 3-stage hydrogen bomb, the equivalent of 50 million tons of TNT, called Tsar Bomba. I'll let you guess the country. So, hydrogen bombs can be thousands of times more energetic than atomic weapons, which North Korea has already tested. And since they deliver maximum bang for their size, H-bombs can be more easily fit on a missile and devastate a city. But North Korea probably didn't set off an H-bomb. The seismic readings from the test area are on par with nuclear tests the country conducted 3 years ago, making experts skeptical North Korea has pulled off the expensive and complicated feat of creating a thermonuclear device. You may be wondering how North Korea figured out how to make any sort of atomic weapons in the first place. You can get your history fix from Lizette at TestTube right over here.
Since 2006, North Korea has allegedly conducted 4 underground nuclear tests, roughly one every 3 to 4 years. The presence of radioactivity has suggested that these have indeed been nuclear weapons.
Are you worried about North Korea, or is their bark worse than their bite? Tell us your thoughts in the comments or on Twitters with the hashtag AskDNews. Subscribe for more, and I'll see you next time on D News.